Right now, you are moving at over 1,000 miles per hour. You don't feel it, you don't see it, but the ground beneath you, the chair you're sitting on, your entire body, all of it, is spinning through space at a speed faster than a fighter jet. So what would happen if, for just 1 second, that spinning stopped? Not slowed down, stopped completely. The answer is more violent than almost anything you've ever imagined. Here's the thing most people get wrong about this question. They imagine the Earth stopping like a car stopping, a little jolt, maybe you stumble, and then everything's fine. But that's not how physics works. And by the end of this video, you'll understand why even 1 second of a stopped Earth could be one of the worst events in human history, and why the planet itself might never fully recover. Let's start with the speed we're actually talking about. If you're standing at the equator, Earth's rotation is carrying you eastward at roughly 1,000 miles per hour, about 1,670 kilometers per hour. That's faster than a commercial airplane. Here's the part that matters. You're moving at that speed, but you don't feel it, because everything around you, the air, the buildings, the ocean is moving at the exact same speed in the exact same direction. This is the same principle that lets you walk around inside an airplane cruising at 500 miles per hour. You're not fighting the plane's speed because you're already moving with it. Now, imagine the plane hits a wall. Instantly. That's essentially what we're describing. If Earth's rotation stopped in 1 second, the surface and everything on it would still be moving at 1,000 miles per hour. But there would be nothing to keep carrying it forward. This is Newton's first law in action. An object in motion stays in motion unless something stops it. Your body, the oceans, the atmosphere, none of that would know to stop just because the ground did. Scientists at institutions like NASA study rotational dynamics like this, not because they expect Earth to stop, but because understanding these forces helps us understand planetary stability, asteroid impacts, and even why some moons in our solar system wobble or tumble unpredictably. So let's break down what actually happens, piece by piece. First, everything not bolted to bedrock gets launched eastward at highway, plus 700 mph speeds. Buildings would shear off their foundations, trees would be ripped from the ground. The human body unsecured would be thrown with the same force as a 1,000 mile per hour car crash. Survival, for almost anyone outdoors or in a typical building, would be essentially impossible. Second, the atmosphere. Air is also moving with Earth's rotation. If the ground stopped but the air didn't, you'd get wind speeds far beyond any hurricane ever recorded, comparable to Category 5 hurricane winds, but globally, instantly, and everywhere at once. Third, the oceans. This is where it gets even stranger. Earth's oceans bulge slightly due to rotation and gravity. If rotation suddenly stopped, that water wouldn't just sit still, it would surge toward the poles in catastrophic planet reshaping waves. Researchers who model planetary water dynamics, including teams referencing data from NASA's Jet Propulsion Laboratory, describe ocean behavior under extreme gravitational or rotational shifts as one of the most destructive forces imaginable, capable of redrawing coastlines entirely. But here's the strange part. After the chaos of that single second, gravity would still work normally. Earth would still orbit the Sunday. Days, technically, would stop existing the way we know them, because without rotation, one side of the planet would face the sun permanently, while the other side would be locked in endless night. Here's where most people assume the story ends. Earth stops, disaster happens, and then life adapts. But that's only half the story. The side of Earth facing the sun forever would slowly heat up far beyond habitability. The dark side would freeze. Without rotation, the magnetic field generated in part by the churning of Earth's molten core, a process tied to rotational forces, could begin to weaken over time. That magnetic field isn't just a compass needle curiosity, it's a shield. It deflects solar radiation and charged particles from the sun that would otherwise strip away our atmosphere, the same way scientists believe happened to Mars billions of years ago, according to research highlighted by NASA's Mars atmospheric studies. In other words, a single stop second could set off a chain reaction that, over a long enough timeline, makes Earth more like Mars, cold, irradiated, and stripped of the atmosphere we depend on. Scientists weren't expecting a 1-second event to have million-year consequences. But that's exactly how interconnected planetary systems work. Gravity, rotation, magnetism, and atmosphere are not.